am Dr. A. Anita, belonging to the Department of Chemistry of VV Vanniyaparamal College for Women, Virudhunagar. In this module, we see about the introduction about the gaseous state and about the Boyle's law. In nature, all matter exists in three physical states versus solids, liquids and gaseous state. These are the three physical states of matter. In our day-to-day life, while the food we eat mostly in the solid or in the liquid form, the air we breathe is in the gaseous state. Similarly, the atmosphere consists of the gaseous particles. In this module, we have a slight introduction about the gaseous state, its characteristics, its parameter, and then followed by the renowned gaseous law, that's the Boyle's law. Before getting into it, we have seen the introduction of the gaseous state. The gaseous molecules are far apart. They are not closer to each other. So, their intermolecular force of attraction is less. They are spread out. They are not in a precise environment or in a congested environment. They tend to exist far apart. Therefore, the intermolecular spacing between the gaseous molecules are very large, whereas the intermolecular force of attraction between the gaseous molecule is very low, and they have no rigid structure. They occupy whatever the volume available. It expands the ample amount of volume. When compressed, it will comes to a smaller volume. Therefore, the gaseous molecules are defined by the properties like it has less intermolecular force of attraction and it has intermolecular distances again high, and it doesn't have definite volume or definite shape and size. These are the properties of the gaseous molecules, whereas it differs from the liquid and the solid state. In the solid, the intermolecular force of attraction is somewhat higher than that of the gaseous state, and it has a definite volume and not a definite shape or size. Whereas in the solid, all the particles, solid particles are come closer to each other, and therefore the intermolecular force of attraction is very large and the intermolecular spacing is very low, and it has a definite shape, size and occupies a definite volume. And in this way, the gaseous molecules are different from that of the solid and the liquid state. Now we can see about the general characteristics of gases. The first one is its expansibility. The gaseous molecule occupies whatever the volume available. If one molecule of a gas can be expanded to a huge volume of a container. Whereas it has the extreme opposite of this character also. That is the compressibility. When it is compressed, or when a gas in a cylinder is compressed by using a piston fitted with a cylinder, it can compress itself to a very little volume. And it has one more important property, diffusibility. It can diffuse rapidly into each other, and it forms a homogeneous mixture. That is why the aerated cool drinks are available, as the gas forms completely diffused with that of the liquid molecules, where the carbon dioxide mixed with water is often used as a aerated cool drinks. The next important property is pressure. Gas exerts pressure due to its collision with the collision of molecules with the container or with one another in all the directions. The next important property is effect of heat. When gas confined in a vessel is heated, its volume increases, thereby its pressure decreases. But on the other way, when we compress, its volume decreases as well as the heat is also increases. These are the 5 important properties of the gaseous molecules by which it is characterized. The next is the parameters which are required to define the properties or a state of a gas are of 4 types, that is pressure, volume, temperature as well as the number of moles. First we can come to the volume. It is the volume of the container in which the gas is present. As the gas has high expansibility, the volume of the container is the volume of the occupied gas. The next is the pressure. The pressure is defined as the force exerted by the gaseous molecules per unit surface area in contact. That is, the force per unit area is always defined as the pressure. The pressure of the gas molecules is the force exerted by the gaseous molecules per unit area. It can have different units like pascals, star, as well as millimeter of mercury. The pressure of air that can support 760 millimeter of mercury above the sea level is called as 1 tar, or otherwise it is called as 1 atmospheric pressure. The relationship between the units of millimeter of mercury, tar and atmosphere is given as 1 atmosphere is equal to 760 millimeter of mercury, and that is equal to the 760 tar. And these are all the same units, the different units for the gaseous state. The next is the temperature. The temperature of the gas is measured using two different units, that is the centigrade or Celsius, or Fahrenheit or Fahrenheit. But the SI unit of the temperature is Kelvin, and the conversion for the Kelvin scale and the centigrade scale is Kelvin is equal to degree centigrade plus 273. And the next is the number of molecules, number of moles of a gas. It can be easily determined by dividing the molecular mass of the gaseous molecules by the molecular mass. If we take 20 gram of nitrogen means, then 20 gram divided by the 28 molecular weight will be given us the number of moles of a nitrogen gas. We have to take a particular weight of a gas. When it is divided by its molecular weight, then we can determine the number of moles of the gas. And these are the 4 state variables for the gaseous molecules. If we have the 4 properties, then we can given the state of the gas. Next is the first important law of the gaseous state, that's the Boyle's law. The Boyle's law states that at constant temperature, the pressure of a fixed mass of a gas is inversely proportional to its volume. If the inverse relationship means if pressure is increased, volume decreases, or if volume is increased, pressure decreases. If the pressure is increased by 3 times, then the volume will be reduced by 3 times. That's given by this diagram. If the volume is 1 liter, is reduced to 0.5 liter by increasing pressure. On increasing pressure, volume decreases, whereas the reverse case, on decreasing the pressure, the volume will be increasing. That is, it can be converted into one form to another by increasing or decreasing the pressure. The next is, it is mathematically represented as V is inversely proportional to P. That is, V is proportional to 1 by P. On rearranging, to remove the proportionality, we can multiply it with the proportionality constant, and therefore P1 into V1 is equal to constant, that is equal to P2 V2. On plotting a graph between volume versus pressure, we are having a hyperbolic structure. Whereas on plotting V versus 1 by P, that is volume versus the reciprocal of the pressure, we can get a straight line curve with positive slope. Therefore, on the relation, this graph infers that the volume is inversely proportional to pressure. Now we can see how the Boyle's law can be demonstrated, and this can be demonstrated by using a U-type jar where V is the volume of the gas occupied. On pouring mercury through this jar, we can get this H1. On further adding mercury into its level increases, whereas the volume gets decreases. That is, V2 is less than that of the V1. On further adding mercury, the level height H3 further increases than that of the H2, whereas the volume decreases. This mercury increases the pressure, thereby the volume gets decreases. On adding less amount of mercury in this, the pressure will be somewhat lower, whereas the volume occupied by the gas molecules will be increased. Whereas in the first case, the volume is very high and the pressure exerted by the mercury is very low. That is determined by the height of the mercury level from this. This clearly explains the Boyle's law. On increasing the pressure, the volume decreases, or if it volume occupied by the gas molecule is high, then the pressure is decreases. Pressure of the gas molecules decreases. In our day-to-day life, we can come across this in many situations. If we want to make the pressure lower, then we have to increase its volume, or vice versa. If we want to have, if we are provided with only a small volume, then in that area the pressure will be surely high. This Boyle's law forms the basis for the existence of the substances in the gaseous state, and we can see about the Charles law, Avogadro's law, and further in the next module. Thank you.